So like I was talking about the basic concepts in continuous graph, right? So now we are going to take one example. Actually, it's the banking applications, right? How the banking applications happens in batch graph, and also the multiple scenarios in banking applications happen in the corresponding continuous graph, right? So there are most of differences actually, and which components can be replaced by you know continuous graph component, so that it can be avail the same functionality, right? So there are three data sets basically. The customer data we have, like there will be a customer ID, customer name, address, and all. So that is common data set. And then the customers are going to be having an account in particular bank, right? So there are account ID and customer ID, what type of account it has, and what is the amount in that, what is the balance, and what is the movement happens, the transaction. I call it as a movement actually. And the what is the particular movement feed, right? So there will be three feeds: a customer account and movement feed in the like kind of transaction feed, basically movement ID in the sense of transaction ID. What I am why I am saying movement is movement of amount from in and out, okay? Credit and debit, and those kind of things, uh, you know in out, or that kind of. And what is the movement amount, and what was the date when the transaction happened, or the movement of the fund happens, okay? So in that context, like what is going to happen is, so let's hook up to the particular scenario actually. So I'm going to open one of the, yeah, account processing site. Let's say we have a account processing graph, wherein what we need to do is, we will have a new account coming in as part of queue. Account queue is there. So somebody is putting the accounts, right? And what we need to do is, we have a data warehouse, in the background, right? Which is we are using database as a persistent data storage, okay? And we are receiving the account detail as part of queue, account queue, okay, which are sitting in the AI serial queue, which is a physical location into our AI server, right? And subscribe is a component which is going to read that queue, and then the rest of the processing happens until the data is safely loaded into the database tables, right? Condition update table, or maybe the publishing. So some part we can publish it. We will see what we are going to publish over here. So how many continuous flow components we have used? So subscribe component, which is going to read the data from the queue, and then there is a continuous join with DB component. Then there is a continuous update table component. Then there is a multi-publish component. So there are four different continuous graph, yeah, continuous flow components I am going to use in the basic account processing. So what are the different things here is this, that first we are going to check that a particular account is already existed in the account table or not. To do that, we will have in our this graph, right? What we do in batch graphs? Probably we will create the account table lookup, right? And then we will check in that lookup if that using the lookup function in the reformat, let's say. And if the account is there, is okay, otherwise we will create the new account. But in the case of continuous graph, we will not have a kind of lookup, right? So because the data is continuously coming, right? And continuously we are going to check the data, and if that is not there, then we will create that account, and then new account is getting inserted. Those kind of things we need to do, and this will keep on running, right? So in real time we cannot achieve using the lookup, therefore we are using the continuous join with DB command. So what it will do is, it will select the data from the count table, right, while running the graph. If that is there, then is okay. Otherwise we will create the new account over here, and then we will do the rest of the processing, right? So let's talk about continuous join with DB a little bit more with respect to the different parameters it is going to offer, right? So there is an we know that how join with DB works is, so we will have a atomic data, right, coming in. We will have account ID, and what we will check it, select account ID. Yeah, select store from account table wherein account ID is equal to coming in account ID, right? So that's the query we are going to fire to the database, right? So if that is returning true, is okay. Otherwise, this is going to be a new record, right? So if account is already available, then is okay. Otherwise, it will going to create the new account, right? So what is the case query result? And there is a checkpoint action. So what is there is, so each and every time, so so we know that subscribe is going to emit the checkpoint, right, with a certain number of records. Maybe it is a one record, or it could be 10 records, right? So these two parameters, case query result or check true, if is the case query result true is in the sense of whenever it will hit the database for a particular atomic, particular account ID, if the next coming in account ID is same, and we don't want to hit the database again with the same atomic variable in the sense of same account, then what we do is we cache the result, cache query result is true, so that for a subsequent account ID, we don't want to hit the database again, rather than, because we will know the result, right? So in the, because we have received the result already, so we'll keep the result in the cache, query result in the cache itself. Okay, there is a max score value assigned to it, continues with join with DB. So in that cache, we will hold the result, and it will be used for the next incoming data. But in this case, what we will do is we will not query the result, cache query result is going to be false. Okay, or it could be true also, based on the number of configuration, right, how many records is there in the checkpoint. So each time, what is going to happen is, and there's also checkpoint action clear case, in the sense of, as soon as checkpoint comes, if we do clear case, then there won't be a query result for that record which is going to come in the next checkpoint. So let's say 10 records. If checkpoint finished, if we specify clear cache, in the sense of anything which is available in the cache is going to wiped out, and the record which is coming into the next checkpoint, I mean the first record of the next checkpoint, is going to hit the database again, irrespective of whether it's the same account ID or a different account ID. But within a checkpoint, if we specify this kind of configuration, it is going to, it is not going to hit the database again with the same account ID, but rather it will use the previously cached result. Okay, so that's when these kind of configuration comes into picture. Okay, so this is how it happens, and then there will be a reformat. Okay, we will create the new account ID. Okay, we will assign something, some we'll have a next in sequence kind of things, like, and then what we will do is we will replicate it, we will create an account, and we insert the account and using the continuous update table. So the continuous update table will have an insert SQL file and update SQL file. Okay, SQL statement, or insert, like it happens in update table database component, right? Similarly, there is a continuous update table also comes with the insert SQL statement, or a update SQL statement. So herein, because we have a new account, so we will have a insert SQL statement. So insert into account this kind of things, right? So account ID and so on, you know, or other different account types and all those things. Similarly, we will have a so once the account is created, we will have initial deposit, right? So let's say assign some initial deposits over here, and we are going to put all those records into the another ab initio queue. Okay, a serial queue, a transaction log queue, that is called transaction log queue. Okay, so we will use the multi-publish. So why we use multi-publish is, if we have to publish the data into the queue, is we use the publish component, right? But here I am using multi-publish. Why we are using multi-publish is, we can publish the data into a same queue from a multiple graphs, or also from the multiple flow. So let's say we have another flow over here down, and same kind of records I want to publish. So what I can use it, I can use the multi-publish, and I can specify same queue over here so that there won't be any error. Okay. So same queue I can use to publish multiple times within the same graph, or maybe a different graph also. Let's say my other graph is also running. I can use the same queue, and but I need to use multi-publish component to configure this same queue. So that's when the multi-publish comes into picture. So we talked about continuous update table. So let's talk about continuous update table more also. Like here in the commit table and commit number things will not be effective because it's a continuous flow graph. This is not a batch graph. Therefore, here the commitment happens based on the checkpoint, right? Okay, so therefore those the legacy, not legacy, the batch graph parameter configuration will not matter over here. Okay, so subscribe component is going to read the data, continues going to join with DB will check the occurrence availability of the account, and the continuous update table is going to insert those accounts, new accounts, and multi-publish is going to be publish the data from the flow. Okay, so here we have a transaction is going to be published, actually transaction with the particular account ID and with the initial deposit. So there will be some DML basically. Let's say what DML, like transaction, this kind of DML like account ID, moment ID. There will be nothing, right, for moment time, moment date. So let's put the data for initial transaction for the initial deposit, let's say zero money, or maybe a kind of minimum amount, right, 500 or 1000 rupees, because this is first transaction, right? So in movement type, a movement amount is, let's say, 1000 rupees. Movement date is current date, and account ID whichever we have created. A movement ID also we will be configuring it, or maybe we will have assigned -1 for movement ID over here, and the next time when we process the transaction, right, so we will assign the particular transaction ID over there. Okay, so that's the basic account processing. So the batch graph is little different than here, right? So in batch graph, what we will do is we will prepare the maybe file over here, or here also we can have update table component. Okay, and here what we can do is we can use the lookup. Here we can use the input files, right? So input table and input file, because they cannot emit the checkpoint, right? Therefore we don't use in the continuous graph. Okay, so thank you so much. Please subscribe my channel, and we are going to see rest part of this banking application, right? The B and C point. Okay, and yeah, and the miscellaneous components which are going to be used as part of that processing, we are going to see in the coming videos. And finally, we are going to see the optimization technique in the continuous graph and recovery mechanism in the continuous graph, that is in the pipeline. Okay, thank you so much.